So two mirrors make an angle of 120 degrees with each other. A ray incident on mirror 1 at an angle of 65 degrees to the mirror. Okay. Here, some of you took this as glancing angle, but the ray incident on the mirror. So the fact that to the mirror does not mean, okay, if it's glancing angle, it will be well stated. So we have two mirrors. Mirror 1, the drawing very, very important. And then mirror 2. They are mirrors. So one end is coated. So if this is mirror 1, this is mirror 2. The angle between them 120 degrees. Then a ray incident on mirror 1 at an angle of 65 to the normal. So a ray incident on mirror 1 at an angle of 65. So I'll need the normal. So this is 65 degrees to this mirror M1. Of course, it will reflect. An angle of reflection must be the same as the angle of incidence. So let's assume, let me extend this mirror. Let's assume its incidence here. I think the reflection of light. Let me bring it, draw it here. So this is 120. A ray, mirror 1, mirror 2. This is 65. And it will reflect. So this is also 65. So the ray incident on mirror 2. Find the direction of the ray after it is reflected from the second mirror. Find the direction. Direction is angle of the ray after it is reflected from mirror 2. So when it's incident on mirror 2, it will also reflect. And the angle of incident would also be equal to the angle of reflection. So let's assume there's the second normal after the incidence on mirror 2. So this becomes the reflected ray. Okay. Now we are using the principle of reflection or the rules. Angle of incidence equals angle of reflection. Incident ray, reflected ray at the point of incidence all lie in the same plane. So that is basically what we are using to solve this. So if this is 65, angle of incidence is 65, then this angle, the glancing angle, would be 90 minus 65. Okay, which is 25 degrees. So this is 25 degrees. Now, if this is 120, this is 120, this is 25. We have 120 plus 25 plus the unknown x equal to 180. Therefore, the unknown is equal to 180 minus 145. Okay. And this is also equal to 35 degrees. Lenny, Leonard, mute yourself. Leonard. Leonard, they are calling you. So this is 35. So if this is 35, this will be 90 minus 35. Leonard, 90 minus 35 is
sir, please, I didn't get it.
Yo,
From the X, I like
how will
your.
you get
I
it?
didn't see your screen at first, sir.
Okay, no problem. So 55. So if angle of incidence to mirror 2 is 55, then the angle of reflection is also 55. So that the other angle. So if the question is saying that find the direction of the ray after it is reflected from the second mirror, this is the incidence, this is the reflection. So this whole angle becomes the direction of the ray after it is reflected from mirror 2. So the direction of the ray after it is reflected from mirror 2 is 110 degree, 2 times 55. So that the direction must be 55 degree. So a lot of you took it as just the angle of incidence. But we look at the incident ray coming from mirror 1 and then the reflected ray from mirror 2, moving away from mirror 2 to be the direction of the ray after reflection from mirror 2, 110 degree. Please, is it understood?
Yes, sir.
A lot of you took this as 55 and I was worried. Then the second question, if a light ray strikes the horizontal mirror as shown. So let me draw the mirror. Two mirrors inclined at theta. The ray doesn't seem so parallel. Mamiya.
Please, can you come again on the reason why it's 110 instead of the 55?
Mamiya, listen to the question. Find the direction of the ray after it is reflected from the second mirror. So we are looking at the direction of the reflected ray after it is reflected from the second mirror. So basically, we are looking for the direction of this. The direction of this. Okay. So look at it. Where is it coming from? It is coming from mirror 1 and then reflected. So if we are looking for the direction of the ray after it is reflected from mirror 2, it is. So Mamiya, every angular measurement has its reference. This is the reflection after intersection with this. Where is the incident? This is it. So we measure the reference point of reference of measuring the reflected ray is from the incident. The incident ray from mirror 1. Mamiya, is that okay? So the reference point of measurement is from the incident ray from mirror 1. So the angle between the incident and then the reflected gives it the direction. Mamiya, are you okay? Mamiya. All right. Question 2. Question 2. You see, the rays are not directly parallel to the mirror. Hey, Leonard, you're always talking. Today I have a bit of network challenge, so okay. The reason for occasional drop in communication. All right, so a ray hits this incident, reflects, reflect here, and then let me pick the main drawing. Good. And then after reflection, the emerging ray goes like this. Those of you who are drawing this as if this ray, the incident ray is parallel to mirror 2. No, it's not like that. It's not like that. Mr. Sarah, I'm teaching you. Yes. That'll be 12. Okay. So, incident, and this angle is beta. The instruction is that we are to show that beta, we have to show that beta is equal to 180 minus 2 theta. So this is theta. So this is what we have to prove. Beta is equal to 180 minus 2 theta. This one, a lot of you managed to get it. They use they use tactical means to get it. Some of the solutions, when I look through, I don't even understand. All that I see is that it has been proved. But I could,
the power of rocket science.
I can see that. I don't know if some of you fear applying whatever the concept you've learned. What is the concept? We are always using the laws of reflection. Incident ray, reflected ray, normal lie at the same plane, and angle of incidence equals angle of reflection. Just apply these rules, and that is, use sum of angles in a triangle, blah, 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 and you get there. Okay, but you don't draw it to look as if this is parallel to this mirror and the emergent ray is also parallel. No, that's not what you were given. So fasten your seatbelts, see how I'm going to analyze it. Once I have angle of incidence and then angle of reflection, it means there must be a normal. So draw the normal to the mirror. First mirror. Then in the second one, in a second mirror, this becomes the incident ray, and the emerging ray becomes the reflected ray. So draw a normal. The normal must divide the distance into 2. So I'm taking this to be first normal N1, taking this to be second normal N2. This is angle of incidence I. It must be equal to angle of reflection, so II. Now, class, if this is I, what will be this angle? What will be this angle? Quickly, somebody to respond. If this is angle of
90
incidence,
minus I.
so 90 minus I. Thank you. Let's assume here the angle of incidence is X. Angle of reflection is also X. What will be this angle? What will be this angle? Quick one, quick one. Oh, if this is X, this is the same thing here. Caleb,
Sir, please,
answer.
90 minus X.
90 minus X.
Minus X.
So 90 minus X. So let's label maybe A, B, C, D. When you pick triangle A, B, C, we have theta plus 90 minus X plus 90 minus I equal to 180. So when we sum this up, we have theta plus 180 minus X plus I equal to 180. We realize that this and this will cancel, and theta will be equal to X plus I. Understood? Please, is it part understood?
Nope.
Then let's
Sir,
pick
please,
triangle.
can you go over?
Oh,
Just go over.
all that I'm doing is that after determining 90 minus I, 90 minus X, I'm summing them up. Sum of angles in a triangle and equating to 180. That's all that I'm doing. Okay. So let's do same for triangle BCD. We have triangle. So let's sum all the interior angles. This is 2I plus this is 2X. The angle at B is 2X. This angle is not known. Okay. So if let's assume that is Y. Y must be equal to 180. The same reason, sum of angles in a triangle. So we have Y is equal to 2. Y is equal to 180 minus 2 out I plus X. Now we have identified X plus I to be equal to theta, isn't it? So we can say that 180 minus 2 in place of I plus X theta, and by vertically opposite angles, Y is equal to beta. By vertically opposite angles, the unknown angle which we are representing by y is equal to beta. And so we can say that beta equals 180 minus 2 theta. And this becomes the proof. Please understood?
Yes, sir.
Odrick, mute yourself for me. I think Odrick and somebody else. KJC, your microphone is on. So I'm pleading with you, when the question is given, take your time and apply the concepts, whatever I taught you, the principle behind the topic. Don't be afraid to apply. And gradually, whatever you are asked to do, what would show up. Okay. Looking at it, I thought, no, it's like you fear applying the rules. This is not a difficult question. Any question? Okay, then let's continue. I think I need to mute everybody. Leslie, you are making me less. Leslie, you are making me less. All right. Now, we went through rotation of mirror last time. Do I clean it? Or some of you are still writing? Okay. Silence means clean. Mamiya. Mamiya.
Yes, please.
Did you answer question 2?
No, please.
You think it's difficult?
Yes.
You see, do not be afraid to apply the principle. It's not difficult. It's the questions, solution of them is by the same basics you are taking through. So do not be afraid in applying them. I beg you. All right.
Yes,
So
please.
in applying the concept of rotation of the mirror, we came to the realization that whenever a mirror is rotated through any angle, the angle of, let me change position of what I'm drawing. So if this is the mirror, when not rotated the normal, when you rotate it through an angle theta, the normal changes and theta and the reflected blah blah blah. So if you rotate it through an angle theta, the angle between the reflected rays become 2 times the angle of rotation. Now, in application of this, in using this to solve problems, sometimes when a mirror position is like this, there can be a mirror and then a screen. The vertical line is a screen. So when the mirror is not rotated, an incident ray hits on it and then creates a spot on the screen, such as this. So this is a reflected ray when the screen is not rotated. Incident reflected. Then you can also be told that when the mirror is rotated through an angle theta, it forms another spot on the screen. So this is a rotation. After rotation alpha, another spot is created below the first spot. This is the first spot. Spot 1. When the mirror is not rotated, then after rotation, a second spot is formed. This is spot 2. After rotation of the mirror. Then you can be asked either to calculate the distance between the two spots or any of them. Okay. The application is that if the angle of rotation is alpha, what will be the angle between what will be the angle here? Yes.
2 alpha.
So this will be 2 alpha. Okay. Then depending on how the question is given, you can be asked to calculate for this distance, the distance from the mirror to the first spot, or the distance from the mirror to the second spot, or the distance between the two spots. And you can do this using either Pythagoras theorem, trig ratios, trigonometric ratios, or the sine rule, or cosine rule. So using whichever rule to use to find whatever the question is given, okay, will demand any of this. So you can, that is it. So it depends on what you are actually asked, but it's basically apply the principle of trigonometry. Once you know this, when one is given, you can find an unknown. So I'm going to give you a question, then we try our hands in applying this rule in solving a problem. Application under rotation of mirror. Hold on, I'm retrieving a question for us to try. All right, listen to this question. A ray of light reflected from a mirror is 750 centimeters from a screen. A ray of light reflected from a mirror, which is 750 centimeters from a screen, creates a spot on the screen. Let me forward the question into the group. Okay, so it's been forwarded. So a ray of light reflected from a screen, reflected from a mirror, which is 750 centimeters from a screen, creates a spot on the screen. If the spot moves along the vertical plane, if the spot moves along the vertical plane through a distance of 620 centimeters, through what angle in the vertical plane must the mirror be rotated? If the spot moves along the vertical plane through a distance of 620 centimeter, through what angle in the vertical plane must the mirror be rotated? Also, determine the angle of rotation of the mirror. I want you to quickly, within 5 minutes, let's see what you can do whilst I take a shot of attendance. So try this within 5 minutes time, and then I'll get back to you. So it's 12:38, start work. Please, drawing this is very, very important. So the question is about a ray of light reflected from a mirror, which is 750 centimeters from a screen. So the mirror is at the distance from the screen to the mirror. This distance is 750 centimeters. It creates a spot on the screen. So create a spot on the screen. Now, if the spot moves along the vertical plane, so you see the spot is formed on the screen. So in this case, this becomes the first spot, spot 1, because after it is rotated, the spot moves up, moves vertically along. If the spot moves along the vertical plane through a distance 620, meaning the first spot and the second spot, the distance between them is 620 centimeters. Okay, but this second spot will be formed after the mirror is rotated. So after rotation, the distance between the spots is 620. All right. Now, through what angle in the vertical plane must the mirror be rotated? So, you see, this is an angle in the vertical plane, the same angle. So that's what we mean. We are actually to look for angle, the angle here, okay, within the vertical plane. But we understand that when a mirror is rotated, the angle between the reflected ray, don't forget the reflected rays produce the spots. It is the reflected rays that produce the spot. So this is the first reflected ray. This is the second reflected ray. And so if the mirror is rotated through this angle, alpha, then the angle between the reflected rays must be 2 times alpha. This angle is what we are asked to determine. Please, is that okay? So we know this side of the triangle. We know the vertical, this side of the triangle. We are to determine this. Now, because we are not so sure whether this is perpendicular, we can use something else, either sine rule. Let's use the sine rule to find this angle, which we are representing as 2 alpha. Okay. Hello, are you there? Hello, class, are you there?
Yes,
Yeah.
So in most applications, okay, you see, when we use sine rule, we have sine of this angle, maybe theta, over 620 must be equal to the sine of any other angle. We are assuming this is not known. Maybe beta, sine of beta over, we don't know the spots. We don't know this spot. So sine theta over sine theta over 620, which is this, then it should be this. Maybe this is beta. Sine beta over 720. In this particular case, when we use sine rule, because we don't know all the three angles, okay, it won't be possible. So usually for screen, the first incident ray, this first incident ray is taken to be perpendicular to the spot or the screen. Okay, at your level, that is how we usually set the question, that the first incident ray is perpendicular to the screen, so that this will be 20, and we can either use trig ratio or this to find. If that is the case, then instead of using sine rule, even though we can use it, but instead of using sine rule, we can easily use tangent. Rather, when we take tangent of this angle theta, it is equal to the opposite, which is 620, divided by the adjacent, which is 750. So we take the ratio and then take the tan inverse of the ratio to get our answer. Please do that for me. Take the tan inverse of 62 over 75. Please. Mami Yanko, I'm waiting for you.
39.5794.
So give me the answer to the nearest degree.
Okay, let's 40 degrees.
It's 39 point what?
5794.
Okay, so approximately 40 degrees. So this must be the angle through which the mirror must be rotated within the vertical plane, so that we can have the two spots at this distance or interval. So if theta is equal to 40 degrees, then Nana Safo, what must be the angle of rotation of the mirror? Nana, what must be the angle of rotation of the mirror? Oh, Nana, Safo isn't there.
Please,
Mm-hmm.
the beta times 40.
Nana, we are looking for the angle of rotation of the mirror. If the angle between the reflected rays is 40 degrees, what must be angle of rotation of the mirror? All right. Whilst Nana is thinking through it,
90 minus 40.
Nana, you are not applying the concept. Nana, you are not applying the concept. I mean, let somebody else answer. I want somebody else to Au revoir.
Please 20.
Why is it 20?
Because the theta was equal to 2 alpha. So to get only alpha, we have to divide by 2.
Nana, did you hear that? So the angle of rotation between the two mirrors is twice the angle through which the mirror is rotated. Nana, do not forget, I beg you. All right. Another question for the house to try. Another question. So listen, Erefua, your hand is
Mr.
up. Hello.
Yes, please. Please, I wanted to ask that, can you come again with why we are using the tan?
You see, we under reflections, we always take the first ray to be perpendicular to the screen. Unless an internal angle is given, which will necessitate that you use the sine rule or cosine rule. But in this particular question, there is no other internal angle given. Okay. If there is no other internal angle given, then take the first incidence ray to be perpendicular to the screen so that you can use the trig ratio, either cosine, sine, or tangent. So that is what we considered. Are you okay?
Yes, please.
A ray of light is reflected from a mirror. A ray of light is reflected from a mirror onto a screen. Similar question. And a spot is created on the screen. A ray of light is reflected from a mirror onto a screen, and a spot is created on the screen. The mirror is rotated through 13 degrees. The mirror is rotated through 13 degrees, and the spot moves up. And the spot moves up to a new position. And the spot moves up to a new position. If the distance between the mirror and the old spot, if the distance between the mirror and the old spot is 7.3, determine the distance between the mirror and the new spot. If the distance between the mirror and the old spot is 7.3, determine the distance between the mirror and the new spot. 5 minutes. Make me proud. Start work. A volunteer to share his or her answer with us before we solve. Anyone to volunteer? Hey, anyone? Angel. Erefua, Frida. Joel. Joe. Kumsin. Cardmill. Safo. Odrick. Leonard. Obianyeso. Okay. A ray of light is reflected from a mirror onto a screen. So let's draw a mirror. Then a screen. So it is reflected onto a screen. So this is when the mirror is not rotated. The incident ray the mirror is rotated through an angle of 13 and the spot moves up to a new position. So it means that the first spot is below. Then after rotation of the mirror through the third angle, the spot moves up to a new position. If the distance between the mirror and the old spot is 7.3, so this distance between the mirror from the mirror to the old spot there's a new spot. Old. Then spots. New. If so determine the distance between the mirror and the new spot. So determine the distance between the mirror and the new spot. So second reflection, first reflection. Now once the mirror is rotated at 13, Nana Safo, what will be this angle? Nana Safo, if the angle of rotation is 13, what will be this angle? Nana, hurry up. Nana, are you there or you are gone?
Yes, I'm here.
If the angle of rotation is 13, what will be this angle? And now what you-
Times the theta.
So what will be the actual value? And now what is the actual value? Oh, what you are saying is correct. What's the actual value? I'll be asking you questions, Nana, so that you actually sit up, okay? It will help you. So 26. So what is the distance between the mirror and then the new spot? Okay. So in most cases, if all other angles are not provided, then the first reflected ray is perpendicular to the screen. All right, so the appropriate trig ratio to use is cosine. Cos 26 degrees will be equal to 7.3 over emphasis x. What is the distance between the mirror and the new spot? Therefore, x is equal to 7.3 on cos of 26. And that is equal to what? 7.3 divided by cos 26.
8.456.
Give it to me in 2 dp.
8.46.
So that's all. So this is some of the applications of rotation of mirror. It's not difficult. You just need to understand the concept and you are good to go. Any question? All right. If there is no question, Nana, I'm sure you are okay. Is it understood?
Yes, please.
Okay. Let's look at spherical mirrors. So we've done anything plane mirror. The next to look at is spherical mirror. Spherical mirrors are curved mirrors. They are not like the plane mirrors we use, but they are curved mirrors. So spherical mirrors or curved mirrors. There are two types of curved mirrors. We have concave or converging mirrors. And convex or diverging mirrors. So concave or converging and convex or diverging. Okay, so the easy way to memorize it is that this is con. They are all the same thing though, but this one con goes with con V. Then as for this con V, it goes with di. But you later understand features of them. So let's look at structural architecture that distinguishes them, or features of concave and convex. They are features. Concave and convex are akin to when you have a circle like this. One circle, if you coat the back of this, so that light, the moment you coat the back, an object cannot be placed at the back. It's similar to plane mirror. You want to look at yourself in a mirror and then you stand the back. Nothing will happen. No image will be formed. So the moment you coat one side, then light will come from the opposite side, or the object must be placed. So the arrow represents the reflected surface. So when you coat this and then the incident light or the object is placed here, the arrow represents the direction of the reflected surface. Then this becomes what we call concave or converging mirrors. So for concave mirrors, its distinguished feature is that the reflecting surface curves inwardly. So the reflecting surface, which we indicate by the arrow, curves inwardly for concave or convergent mirrors. Then for convex or divergent, it is coated, this side is coated. So the moment you coat one side, light cannot be incidented here. It must be the other side. So this side becomes a reflecting surface. So we say that for convex or divergent mirrors, the reflecting surface curves outwardly. So this reflecting part indicated by the arrow curves outwardly. Whereas in this one, the reflecting surface curves inwardly. These are their special features. So if I draw a curve, just a single curve, I can design it to look like a concave or so just this curve. If I want this to be a concave mirror, then it depends on where I coat. Then I'll coat this side so that this becomes a reflecting surface. And this is concave mirror because the reflecting surface curves inwardly. The same curve I can also coat it at the other side so that this becomes the reflecting surface. And here, the reflecting surface curves outwardly. So these are the differences, the two main kinds of curved mirrors or spherical mirrors. Please, any question? Any question? Sorry. Hello.
Hi.
Hi.
Is that okay?
Yeah.
Give me a second, I'm coming. So this is concave and convex. Now I said that concave mirrors are converging mirrors. Why are they converging mirrors? They are converging mirrors because they are converging mirrors because you see, when you incident for concave mirrors, when you incident rays that are parallel, okay, parallel beam of light to it. This mirror has the ability to converge all rays that are parallel to it to a point. So it has the ability to converge all parallel rays to a common point. So they will all be converged after reflection. They will all be converged to a point. So all rays that are parallel to it are converged at a common point. The reason for which this is also known as converging mirrors, just because they converge parallel beam of light. Okay, they converge parallel beam of light. Please, is that okay?
Yes, please.
And this is the technology used by DSTV multi-choice. You see, their dish is in a concave manner. It is positioned at points so that all rays, electromagnetic radiation that hits the dish in that parallel manner can all be converged at a common point. Okay, and they have calculated this point. We will later go into it. And then you see, the dish is such that there is a feed. There is a feed connecting a particular distance. And this is where the cable to the decoder in your house is picked at. So this point is where all electromagnetic rays that hits in that parallel manner converge. And so all electromagnetic waves converge at the feed, at the common point. And so its intensity is high there. The reason for which the feed of the dish is connected at this point. So this is the principle behind, okay, what the multi-choice and then DSTV also do. So when you curve a dish in this manner, all rays that are hitting in that parallel manner all converge at a point. Okay, so the reason for which concave mirrors are also termed as converging mirrors. Now, for convex mirror, they are called divergent because this mirror is also the type where all rays hitting the mirror in that parallel manner this one diverges or spreads out parallel rays. So once the ray coming to it is spiral, when it hits it, it diverges it. It spreads out spiral beam of light. Spreads out or diverges. The reason for which convex mirror is diverging mirror. So concave converging, convex diverging. Please, is that understood? Class, is that okay?
Yes, please.
All right. Let's look at uses of spherical mirrors. Uses of spherical mirrors. What do we use spherical mirrors for? Uses of spherical mirrors. An example of concave mirror, for instance, can be seen here. This is an example of the reflector in torchlights. You see, this is the coated, the back is the coated end, and the shiny part is the reflecting surface. So this is an example of concave mirror. So you see concave mirror in torchlights, searchlights, headlights, or floodlights, all lights. Okay, or most lights. Torchlights, car headlights, searchlights used in prisons, headlights used by hunters. These days, I don't know if we are still hunting. Okay.
So I think nowadays the miners that use it.
Okay, yes. The miners, yes. Like, and then the hunters light then. Okay. So this convex mirror can be seen in all these lights. Okay, torch lights, car headlight lamps. Okay, searchlights, floodlights, and the purpose for which these mirrors are used for is to reflect light. Reflect light. The torchlight works in such a way that the bulb is just at the middle of the reflector, or so when you on it, okay, this is the reason for which torchlight can travel that straight. So it's like converging the rays and then giving them a path. So it is used as reflectors in torchlight, headlight, okay, car headlight lamps, stadium floodlights. It reflects and then give it to follow a particular direction. So that is one usage of convex mirror. They are used as reflectors, reflector in torchlights, searchlights, floodlights, so minus headlights, etc. It is also used in shaving mirrors. Also used in as a shaving mirror. It can also be seen in, I think, astronomical telescopes. It is also used in astronomical telescopes. So these are just a few of the usage. Then, I said concave rather, sorry, concave or convergent, and then convex or divergent. Can you share with me some uses of convex or divergent mirrors? Can you share with me some uses? Anybody, if you know of any. If you don't know, let me carry on. Convex or divergent mirrors are used as, Gabby,
And they are used in sunglasses and shades.
okay. So used in sunglasses and shades. So sunglasses. Basically to disperse or diverge the UV light from the sun. 2, they are also used as side view mirror of cars. Side view mirror. Side view, head view, or head level. Of cars. So the mirror at the side of cars, they are not plain mirrors. Neither are they concave mirrors. They are convex or divergent mirrors. And we shall later understand why that's usage. 3, they are also used, Elizabeth.
Please, there is in binoculars and telescopes.
Telescopes, it is the concave. I spoke
Okay, there is in
about,
binoculars.
no, binoculars, they are not
Okay.
mirrors.
Okay.
Plain mirror is used in periscope, mirror periscope, but they are not curved mirrors. They are for periscope, it is plain. Then convex mirror is also used as security mirrors in supermarkets. So for security in supermarkets and shops. You see, Nana, go ahead. Your hand
It's a
is up.
laser.
Okay.
It's a laser.
Okay. All right. You see, let me explain this. Before CCTV camera came into our system, shops and supermarkets were using very big mirror mounted at one corner or one side of the shop. Somebody is always employed. Galvin, mute yourself. A security person is employed to be looking through the mirror so that those who could be smart in a shop can be caught. So they were, before CCTV camera came into the system, it was convex mirrors which were used for security. And that there is a reason for the choice of convex, not concave. Okay. Then it is also used for safety, road safety purposes in curvy roads. So used for road safety at curvy roads. So where the road network is so curvy, as you enter through the curve or advantage points, convex mirrors are mounted so that road users can have a better view, especially at their back, so that you can always easily see when there is an oncoming car and all that. Okay, so these are some of the few uses of convex mirrors. Any question? Any question? Now, the selection of convex mirror to be used for side view mirror. Angel,
Mr. Elia,
ask your question.
please, I wanted to say that they use it in ATM mirrors so that when someone is at the back of you can't see.
Exactly. So that it serves the same purpose as side view for security, and then yes, when you visit ATMs, it's there. But the question is that why convex but not concave? That is something you must understand. So advantages of convex mirror over plane mirror and concave mirrors. Let's look at the advantages. Now, if you choose equal size of the three mirrors, this is plane, which of the spherical mirrors is this? Which one have I drawn?
Is the concave mirror.
Why concave? Why concave?
It's because the reflection surface is pointing inward.
Curves inwardly, the reflecting surface. Good. So I'm choosing equal size, what we technically call as aperture of the three mirrors. When an object is placed here, an object placed in front of all of them. So rays reflecting from at the extremes, at the up larger size of the mirror. The incident, they will reflect. So this gives us the angle of view or field of view of this mirror, plane mirror. Now the same object position, incident rays hitting the extremes. This one converges reflected rays. So reflected rays converge. So look at the field of view or angle of view. Then come and look at this one. The same aperture. Rays hitting the extremes. This one diverges rays. Reflected rays are diverged. So it will spread out. It will spread this out. So look at the angle of view. Compare all the three. You realize that convex or diverging mirror has a wider field of view than all of them. Meaning that if this is used as driving mirror and you look through, you can have a wider view of your back. That is why they are used particularly for side view mirror, so that when you are driving and you look through, you can have the opportunity to have a greater or larger view of your back. The reason for which it is used in supermarkets, when it is installed, you can have a better look of the shopping environment than plain mirror. Than the worst one is the concave. The reason for which it is installed at curvy roads, so that you can have a better look of your driving environment. Is that okay? So this is the key advantage convex mirror has over concave and plane mirrors. Please, any question?
No, sir.
If you have any question, quickly ask, because we are going to look at the evaluation. We really need to do this and wash our hands of it. So the next 20 minutes, I'm going to forward the evaluation form to the group so that we go through it. All right. So we'll continue with spherical mirrors. It is a very interesting area to look at. Please, I just forwarded the evaluation form. Please, let's open it. We are going to go through it together so that we save ourselves from that time of looking at this. So open it. I've sent it to the group. So let's open and then go through it. So Omega teacher evaluation form on your physics teacher. The physics teacher who will take you to Dubai after COVID, okay? So please be assured that all responses will be kept completely confidential. So whatever you write is strictly
I choose not to talk.
confidential. Caleb, you have to care your lip, Caleb. So question, let's go through the first question. Links to joining the classes are shared before the scheduled start time. A, never shared before time. B, sometimes shared late. C, often shared late. And D, always shared before time. The choice is yours. So pick one. How you see Miss Adia in connection with this particular question, or yes, you give it that response. 2, are you true with the first one? Hello, are you true?
Yes, sir.
Question 2, does the teacher skip classes? A, skips class most of the time. B, skips class sometimes. C, never skips class. The choice is yours, but you must be objective, okay? As you have seen me, that produce that objective response. Give the number of times the teacher has skipped classes from 0 to 4. My earphone is off. Then the fourth question. Teacher makes alternative arrangement if he or she is unable to attend classes. A, never makes any alternative arrangement. B, sometimes makes alternative arrangement. C, has never skipped class. 5, teacher is willing to answer your questions privately after lessons. A, never answers my questions privately. B, ignores my private questions. C, sometimes answers my private questions. And D, always answers my private questions. That is to those of you who ask private questions. Then the sixth question. Are reasons given for not answering your questions privately? A, no reasons given. B, sometimes reasons are given. C, yes, reasons are always given. D, not applicable. 7, teacher's voice is very clear during class session. A, voice is always low. B, voice is sometimes clear, other times not clear. C, voice is most of the time clear. And D, voice is clear at all times throughout the lesson. 8, how clear are writings and illustrations on board and screens? A, handwriting is not clear. It is difficult to read. B, handwriting is sometimes not clear. C, handwriting is clear at all times. So you just select. 9, background of the teacher during lessons is A, always noisy and disruptive. B, sometimes noisy. C, always quiet throughout the lesson. 10, the teacher gives assignments on topics taught. A, never gives assignments. B, occasionally gives assignments. C, often gives assignments. D, always gives assignments. 11, I hope I'm not speeding.
No, sir.
Class, I hope I'm not speeding.
No, sir.
No.
Hey, are you there?
Yes, sir.
please.
Class, are you there?
Yes, sir.
Okay. 11. Teacher marks assignment promptly and gives feedback for improvement. A. Never marks assignment given. B. Occasionally marks assignment given. C. Marks some and leaves others. D. Always marks and gives feedback for improvement. 12. How many exercises, tests, and assignments, homeworks, or group works, etc., have been given by the teacher? A. 0. B. 1 to 4. C. 5 to 8. D. 9 to 12. E. 13 to 16. And F. 17 or more. 13. My level of understanding of what is taught is A. I do not understand most of the time. B. I understand some of the concepts. C. Did I A to B? C. I understand most of the concepts. And D. I have excellent understanding of all concepts. 14. Are videos of lessons shared with you? A. Never shares videos or lessons. B. Sometimes shares videos. And C. Shares videos on all lessons. 15. Rate the stability of teachers' internet connectivity. A. Connectivity is always bad. B. Network drops too frequently. C. Network drops occasionally. And D. Network is consistently stable throughout the lesson. 16. The method used in the lesson delivery is A. Less interactive. B. Quite interactive. C. Very interactive. And D. Excellently interactive. 17. Would you like to maintain your teacher? A. No, I wish I have a different teacher. B. Maybe. C. Yes, I will always like him or her to teach me. 18. I will join Omega vacation classes in my next vacation holidays. Will you? Okay. A. No, I will not join Omega. B. I am not sure if I will join Omega. C. Yes, I will definitely join Omega. 19. Did the teacher meet your expectations? So am I meeting your expectations? A. No, my expectations were not met at all. B. Yes, my expectations were somehow met. C. Yes, my expectations were met to a large extent. And D. Yes, my expectations were excellently met. 20. Any other comments about the teacher? This is up to you. You input something. And then 21. Any other comments for Omega management? When you finish answering from 1 to 21, please, you click on submit. If you are done answering from 1 to 21, you hit on submit to actually submit your responses. Is everybody through? Has everybody managed to go through everything?
Yes.
Yes.
Show by hands if you were successfully able to answer everything. Just give me, raise up your hand quickly. I'm watching also. We all went through, so please, I want to see your hands if you have done so successfully. I've seen 10 hands, 11. Oh, only 11 of you were able to do it. The rest of you, what happened? Hello, the rest of you, what happened? Because I can see only 10. I saw 11 hands. Meanwhile, you are more than 25. Okay. So please, if you are not able to do it, at your free time, please go through it and then answer. But I mean, today's opportunity is the best to answer this so that you clear it off from your desk. So I don't actually get why some of you were not. Please do it. Spend time to do it. All right. In that case, this is where we draw the curtains on today's meeting. Thanks for your time. We'll continue on Tuesday next week. Take care of yourselves. May the good Lord be with you, and bye-bye. Nana, okay.
Bye.
Eva, did you answer?
Sir.
Mamiya, did you answer?
So fancy.
Okay. See
Sir.
you. Your assignment, as usual,
Goodbye.
will come. Angel, bye-bye.
Sir.
Leonard, your hand is still up. What a hand.
Good.
Goodbye.
Sir. Ah.